On Earth, we only experience two seasons, summer and winter, with spring and fall in between. But if you travel far enough into space, you will find planets that have many more seasons than us. Uranus is one of them. It has extreme seasons that can last for decades. So, what's going on? Why does this happen? And how do its moons and atmosphere survive such extremes? Keep watching to find out. You already know that it takes Uranus 84 years to orbit the Sun just once, but what does this mean for its climate? Let's take a look at a map of our solar system and start with Earth. Our planet is perfectly situated in the so-called habitable zone of the Sun. This means that most of the Earth's surface is liquid water, which is vital for life as we know it. But if we move farther away from the Sun, we come across Uranus. This ice giant is located beyond the habitable zone, so it's extremely cold there. Its distance from the Sun is 19 times larger than Earth's distance. But if we go even farther, say 20 times the distance from the Sun, we will find another planet, Neptune, which also has liquid water. So why isn't Uranus completely covered in ice if it is so much farther away from the Sun? The thing is, even though Uranus is located farther away, it's still close enough to get warmed by the Sun. In fact, Uranus receives as much energy from the Sun as Neptune does. However, the difference lies in how well each planet can keep this energy. Since Uranus is an ice giant, it absorbs and keeps heat much better than Neptune. If we were to measure the amount of heat coming from these planets, we would find that Uranus radiates less heat than it receives from the Sun, while Neptune actually radiates more heat than it receives. So, why doesn't the heat from the Sun melt all the ice on Uranus? That's because the Sun's rays hit Uranus at a very steep angle due to its side rotation. Only about 7 degrees of sunlight reaches Uranus's poles, which means that for billions of years, they have remained frozen. But here's the kicker. Once every 42 years, the pole of Uranus experiences 6 months each of daylight and darkness. During the 6 months of daylight, temperatures can rise to almost 90 degrees Celsius, which is enough to melt ice. But don't get too excited. For the next 42 years, that same pole will be plunged into total darkness, plummeting temperatures to a bone-chilling minus 224 degrees Celsius. And while you may think that the axis of Uranus is simply tilted over like a top that has lost its balance, that's not the case. In reality, something huge must have crashed into Uranus in the past, knocking it off its axis. But who could have dealt such a powerful blow? Scientists believe that it was a large celestial body that had been wandering around the galaxy until it collided with Uranus. To this day, this mysterious object is still lurking in the distant reaches of the solar system. It's about 12 times heavier than Earth and goes by the name Nemesis. Now let's see how people who live on the equator of Uranus experience their seasons. For them, a single season lasts 21 years. But here's the catch. Each season is twice as long as it is on Earth. Spring lasts 7 years, summer lasts 14 years, autumn lasts 7 years, and winter lasts 14 years. Imagine celebrating New Year's in the middle of summer or Christmas in the dead of winter. This could be a reality for someone living on Uranus. What about the other planets? You may have heard that on Venus, a single year lasts longer than its daylight hours. On Venus, a year is 225 Earth days long, but a day lasts 243 Earth days. This means that Venus rotates incredibly slowly on its axis. Now let's compare that to Jupiter, the largest planet in the solar system. The day on Jupiter lasts only 10 hours. That's less than a third the length of a day on Earth. In other words, Jupiter rotates on its axis 3 times faster than Earth. That's not the only mind-blowing fact about Jupiter. Did you know that it is the only planet in the solar system with a day shorter than a year? On Mercury, a day lasts 59 Earth days, while a year lasts 88 Earth days. On Saturn, a day lasts 11 hours, while a year lasts 29 years. As for Neptune, a day lasts 16 hours, while a year lasts 165 years. Okay, now let's get back to Uranus. How did its atmosphere survive such a brutal tilt? Well, Uranus has a super strong atmosphere that extends hundreds of kilometers into space. When the planet was young, it experienced a lot of volcanic activity, which released gases that formed this thick atmosphere. Uranus's atmosphere is primarily composed of hydrogen and helium, similar to the Sun and most stars. There's also a significant amount of methane, which gives the planet its iconic blue-green color. Additionally, traces of hydrocarbons and other organic compounds have been found in Uranus's atmosphere. These compounds are thought to have originated from the complex organic molecules released by the icy rocks that make up the planet's mantle. But how does the atmosphere handle those extreme temperature swings? Despite its colossal size, Uranus doesn't have a solid surface. Instead, it gradually transitions from a gaseous atmosphere to a liquid interior and finally to a solid core. Although Uranus doesn't have oceans in the conventional sense, scientists believe that under the icy crust, there's a vast salty ocean. It's hidden deep beneath thousands of layers of ice and is estimated to be 3 times the size of Earth's ocean. Moreover, it contains twice as much water as Earth's ocean, making it a true paradise for fans of aquatic adventures. Just don't forget your scuba gear when you go exploring. As for the moons of Uranus, they've also adapted to the extreme conditions. For example, Miranda, one of Uranus's moons, has experienced a series of cataclysms that have left it covered in enormous cracks and faults. Scientists believe that these events were caused by volcanic activity, which released heat from the moon's interior. Despite these dramatic events, Miranda still orbits Uranus every 11 days, keeping it in sync with the planet's extreme seasons. Another strange moon of Uranus is Titania. It has the most craters of any moon in the solar system. Scientists believe that many of these craters were formed by debris ejected from Miranda during its cataclysms. Yet Titania continues to orbit Uranus faithfully every 8 days, enduring the harsh conditions of the outer solar system. Scientists have discovered that Titan has the only known lakes of liquid hydrocarbons in the solar system. These lakes are located near the moon's south pole and are mostly made of methane and ethane. The surface of Titan is covered in a layer of ice that can be several meters thick. Beneath the ice, there's a rocky mantle and a metallic core. The average density of Titan is only 1.8 grams per cubic centimeter, which makes it one of the least dense objects in the solar system. But how did the organic matter on Titan and Uranus's atmosphere end up on the moons? Scientists believe that it arrived along with the building blocks of the solar system 4.5 billion years ago. Back then, there were no planets yet, and the sun hadn't started shining brightly. All that existed were huge clouds of gas and dust floating around. Over millions of years, gravity caused these clouds to collapse and form the cores of planets. And when the planets began to shine, their light and heat broke down organic molecules into simpler forms. Then these simple molecules combined again, creating more complex structures. This process is called photochemistry, and it led to the formation of the organic matter found on Uranus' atmosphere and Titan's lakes. But don't worry, despite the crazy conditions on Uranus and its moons, scientists haven't discovered any signs of life there. At least not yet, so rest easy knowing that your quiet life on Earth is unlikely to be disturbed by little green men anytime soon. Unless, of course, they come from Miranda. Who knows? Maybe they're just hiding from us under thousands of meters of ice. If you enjoyed this video, hit the like button and share it with your friends. Thanks for watching and see you in the next one.